Hello, geometry students. Welcome back to Chapter 10. We are loving circles so far, and we are ready to talk about angles. So what we've done, or we'll keep talking about angles, but we're looking at a different type of angle. So 10.4 is called inscribed angles. Remember, we talked about central angles in section 10.2. Central angles have their vertex on the center, and each side of the angle is a radius. Well, this time, inscribed angles are angles whose vertex is on the circle, and then each one of the sides is a chord. So notice in this angle, I've got R is the vertex of that angle if I'm looking at this angle right here. So RQ is a chord and RS is a chord. So I can be talking about angle QRS is an inscribed angle. So that's really important. You have to look where the vertex is. So remember, central angle has the vertex on the center. Inscribed angle has the vertex on the circle. And we've got chords making up those sides. If I were to highlight this, because I do like highlighting, R is the vertex, and I follow those chords out, shade everything within there, that is my angle that I'm talking about. So I did that on purpose because if we talk about the intercepted arc, remember an arc is a portion of the circle that has endpoints. So the arc that lies inside that inscribed angle. So since I highlighted it, you might be able to see pretty easily that Q around to S is my intercepted arc. Remember, you can call it QS or SQ. Put the little arc symbol above it. So SQ is the intercepted arc. Angle QRS is the inscribed angle. These two things have a relationship just like our central angle and the arc had as well, but it's not the same relationship. Remember, the central angle is the same as its intercepted arc. For an inscribed angle, if an angle is inscribed in a circle, then the measure of the angle equals half the measure of the intercepted arc. So let me highlight this again. So I'm looking at angle 1, right? So angle 1 has its vertex on the circle. I can follow those two chords out, highlight them. So this is the arc, minor arc AB. So minor arc AB, actually let's go with how it says it. The angle equals, I'm just reading right here, the angle equals, so angle 1 is equal to half of the measure of the intercepted arc, which is arc AB. Or maybe it might come in handy if you want to also jot this down. We could say something like 2 times angle 1 is equal arc AB. So if this angle is equal to, say, 60 degrees, arc AB would have to be 2 times that angle. Arc AB would have to be 120 degrees. Or I could give you the other way. I could say arc AB is 100 degrees, which means that angle 1 would have to be half of that, or 50. Right? So the angle is half the arc, or the arc is twice the angle. So let's do a quick practice here. Find the measure of angle P. Angle P. So let me find angle P first. Angle P is right here. It's an inscribed angle. I'm going to highlight that. So my point P, I'm going to follow both of those chords out. And I notice that my intercepted arc for angle P is arc MN. Some of you might already know the answer. If I know the arc, the angle is always half of the angle. So angle P, oops, not 35 squared. Angle P is 35 degrees. Angle P. Find the measure of arc PO. So arc PO, this one's a different one. I'm going to highlight a little different. So arc PO goes from here to here, right? So I'm going to highlight my way in. So if I just trace the chords that cut off PO, I'm looking at this as my inscribed angle. Well, if angle PNO equals 56, my arc is twice as big as my angle, so I'd have to say 2 times 56, or that would be a whopping 112 degrees for this arc. I usually mark them like this. 112, this guy would be 35. Right, so just practicing going back and forth between an inscribed angle and a intercepted arc. All right, so there's a lot of theorems, a lot of things. So really we're going to go through theorems and then we're going to do a practice problem of different types. So Theorem 10.7, you do not have to memorize this. You just need to know if two inscribed angles of a circle intercept congruent arcs, then the angles are congruent. Let me show you this. You know how I like to highlight, right? Let's say I'm talking about arc DC right here. Arc DC. If I highlight arc DC into its inscribed angle, well, I could go up like this, right? Wouldn't you agree that that angle A right there is an inscribed angle that goes out to arc DC? However, let's be sneaky on this. What if I went this way? If I highlighted angle B, isn't that the same intercepted arc? Right? So here's the thing. If arc DC, say this arc out here is equal to 50 degrees, what does angle A have to be? Half of that, so 25. But also because it has the same intercepted arc, what does angle B have to be? Also 25. So angle A would have to be congruent to angle B because they have the same intercepted arc. So it's a sneaky one. You got to work your way in and see what's going on. Notice over here it was just two separate. If this arc FE right here goes, whoops, that's too big. If this arc FE traces into angle A as its inscribed angle, and arc CD traces into angle B for its intercepted arc or intercepted angle, or sorry, inscribed angle, and those two arcs are congruent, say they're both 30 degrees, doesn't angle A have to be congruent to angle B, right? Because they'd both be 15. So angle A is congruent to angle B. So if the arcs are congruent or the arc is the same arc like DC. All right, so that's a sneaky problem. I can see where, it's going to just be seeing that you can find those things. Here's the next one. It's a good one, and it really helps to solve problems quickly. An inscribed angle intercepts a diameter or a semicircle if and only if the angle is a right angle. So what this is saying is if angle B is a right angle, if angle B is a right angle, that means that, do you see that angle B is actually an inscribed angle? And if I know that my inscribed angle is 90 degrees, how do I get my intercepted arc? I double it, right? So this has to be 180, which means that AC has to be a diameter. So if angle B equals 90 degrees, then I'll say arc ADC equals 180, and AC, that was supposed to be an and, AC is a diameter. And because it's got that IFF, if and only if, it goes the other way as well. If AC is a diameter, then angle B ends up having to be a right angle. So use that to your advantage. I feel a little triangle sum theorem popping back up here. Remember, what do the three angles of a triangle add up to? 180 degrees. That's going to be helpful. Keep that in the side. And another theorem, 10.9, please don't memorize it, just know this. If a quadrilateral is inscribed in a circle, remember inscribed means inside. So I've got that ABCD quadrilateral, it's just a four-sided figure. Inside my circle, all of the endpoints, A, B, C, and D, are on the circle. Then the opposite angles are supplementary. Huge important fact. Everybody remembers supplementary, right? What does supplementary angles add up to? 180. Please mark carefully and be careful because I'll try to trick you because that's how I am. It's the opposite angles are supplementary. So in other words, angle A plus angle C has to equal 180 degrees. Or angle B plus angle D has to equal 180 degrees. So opposite angles. There's a reason for that. We can talk about that as we go, but it actually makes a lot of sense if you look at it. So if I were talking about angles A and C, I'll call them 1 and 2. Angle A, its intercepted arc would be BD, right? So angle A is going to be half of BD. But if I look at angle C, its intercepted arc would be this one, which makes up the whole complete circle, but it's half of whatever that is. So there's a reason behind it. You can just trust me, opposite angles are supplementary if it's an inscribed quadrilateral. Has to be a four-sided figure. All right, so let's do a problem or two. Let's make sure everybody's good. It says triangles ABD and ADE are inscribed in circle F, so we know that F is the center. That's actually a really sneaky little clue for you. And it says arc ADAB is congruent to arc BD. So I'm going to mark these arcs as congruent. I'll mark my single dash on the arcs. I'm allowed to do that, right? Find the measure of each numbered angle if angle 1 is equal to 12x minus 8, and angle 2 is equal to 3x plus 8. All right, so we can figure out the measure of each numbered angle pretty easily. Let's start with 1 and 2 because 1 and 2 are the most amount of work. I'm going to just jot down over here that I need to tell angles 1, 2, 3, and 4. You might already know the answer to 3 and 4. So you know how I said that circle F is a sneaky clue? Means F is the center, which means AD is a diameter. Go back to one of those theorems. I can't remember what it was. If that's a, excuse me, if that's a diameter, don't we know that this arc is 180 degrees, which means the other half would also have to be 180 degrees, right? What do you know about angles B and E? This is the important part from one of those theorems. If AD is a diameter, angle E has to be the inscribed angle, or the intercepted arc would be arc ABD. That's 180. Angle E is half of it. So E has to be 90 and B has to be 90. So I'm guessing right now you could pretty easily tell me what angles 3 and 4 are, right? Because remember there's another rule from another section that says if these arcs are congruent, then these chords are congruent. If I just look at triangle ABD, that is an isosceles, a right isosceles triangle. How many degrees do angle 3 and 4 have to be? We're sharing 180 degrees minus the 90 for angle B, so 90 degrees split between those two angles. Sorry, I gave you the answer, is 45 each. Angles 1 and 2, we need to do a little bit of work. We know angle E is 90. I'm seeing triangle sum theorem here. So if I just look at this triangle down here, I can add up the three angles, make them equal to 180. So I've got myself a 12x minus 8 plus the 3x plus 8 plus the 90 degrees equals 180. Some of you probably noticed that we can just take the 90 right out. The two expressions equal 90. That's going to be like 15x plus 90 equals 180. So 15x equals 90, and I believe that's going to be like a 6 maybe. So if x equals 6, everybody can now figure out what angle 1 is, right? Let's put a 6 in place of that x, so 12 times 6 minus 8. That's going to get us a 64 degrees. Go ahead and put that 6. 3 times 6 is 18, plus another 6 is 26. Wouldn't you agree that angle 1 plus angle 2 have to equal 90 degrees? So there's a built-in double check there for you. So some sneaky algebra problems, and we keep recycling old stuff like triangle sum theorems. All right, let's talk about this example. Only reason I want to talk about this, well, two reasons. One is because there's not a diagram, and two is because it's one of the theorems that's going to be helpful. Quadrilateral QRST is inscribed in circle M. So I'm going to just draw circle M, right? M is the center. Do the best you can. Quadrilateral QRST. So draw yourself a quadrilateral. It doesn't have to be fancy. Remember, when you name your quadrilateral, you go around the outside. QRST. Don't skip or go diagonal. If angle Q is equal to 87 and angle R is equal to 102, find angle S and angle T. So I need to know those two angles, angle S and angle T. So this was a theorem that we just talked about. There's a reason behind it, or you can just hopefully know opposite angles are supplementary. Easy peasy then, right? We just go ahead and do ourselves an equation. So angle Q plus angle S, so 87, angle Q plus angle S equals 180. So 87 plus X equals 180. So it looks to me like angle S is going to end up being, what, 93 degrees? You probably just hopped right to your calculator and did that one. If I'm going to find out angle R plus angle T equals 180. So 102 plus X equals 180. So that's going to be something like a 78 degrees. Easy problem once you get that diagram up there and you remember that theorem that opposite angles are supplementary. Do not be tricked into doing anything else. I know this, we don't have parallel lines, so we can't be doing anything with that stuff from way back to chapter 6 or whatever it was. One last example, because this one's a really good one and it pops up a lot. It says to find the measure of angle R. Well, according to my diagram, angle R is 12x minus 3. So doesn't it make sense that we need to figure out what R or what X is before we can do any math? Well, it's an inscribed angle, so I'm going to trace angle R's chords out. So RQ and RT. So here's my intercepted arc. Not very helpful. However, I also have some information on angle S. I know angle S is 9x plus 2. Not super helpful, but let's trace angle S out. So I'm going to trace that chord SQ and ST. Highlight that. What do you notice about those two tracings? Both angles R and S have the same intercepted arc, arc QT. Well, if they have the same intercepted arc, they're both whatever QT is divided by 2, which means they have to be congruent. Angle R has to be congruent to angle S. They have the same intercepted arc. Sorry for my sloppy writing. So I can set myself up a super quick, painless equation. Let's do a little algebra. 12x minus 13 has to be equal to 9x plus 2. So 3x, subtract 9x, add 13. 3x has to be equal to 15. So x is 5. Hit pause if you're not solving as quick as I am. So if x equals 5, we're not done with this problem, right? Because it does say that we need to find the measure of angle R. So angle R is going to be 12 times 5, which is 60, minus 13, which is going to be 47, I think. What if I asked you for the measure of angle S? Are you just automatically going to say, oh, S is 47? hopefully, but you can also do that double check. Put that 5 in there. Make sure that you get 47, because if you don't, then you did something wrong in your solving or your setup. 9 times 5 is 45, plus 2 is 47. So these two guys have to be congruent. It turns out they're both 47 degrees. There's one more example that we could talk about, but let's leave this for later. It's busy and messy, and probably I'll get to highlight to my heart's content. So that is it for section 10.4. Thanks for hanging in there. Have a fabulous day, and I can't wait to talk about these with you.